Hello class, welcome to Geometry Lesson 4.6, which is all about congruence and overlapping triangles. By the end of this lesson, you should be able to use triangle congruence to solve problems with overlapping triangles. So let's jump in with the first example. We have identify corresponding parts in triangles. So if we have figure ABCD, which is a rectangle with diagonals segment AC and segment BD. So if you look, we have that picture over on the right here, and we want to know why is it important to be able to identify corresponding parts in overlapping triangles. So if we look at this, I can break that rectangle up into a couple of different triangles. So if I look and consider triangle ABC and triangle DCB, so ABC is highlighted red, DBC is highlighted blue. Let's practice identifying the corresponding sides and angles between the two triangles by first figuring out our congruent parts. Okay, so this is something that you guys did yesterday in your homework, and you guys got a little frustrated with trying to figure out what lines up with what, and so that's why we're going to practice a little bit more with it. So if I look, I can see that two segments, AB and DC, have the same length. So even though they're on different sides of the triangle, those are our congruent parts. And then if I look to angles ABC, so this angle right here has the same measure as DBC. Okay, they're both right angles. So if you look, our triangles are kind of like reflections of each other, like what we learned last chapter. They don't face the same way. And then segment BC and segment CB, those are also common sides, just like segment AC would be a common side with segment DB. So if I ask you to list all of the congruent parts and the corresponding parts, this is what I would expect you to be able to do. Like I said, you did this a little bit in yesterday's homework, and being able to identify those corresponding angles and corresponding sides is really going to be important in order to help you solve proofs, okay? So practice with that a little bit. Here's a question for you to try. If you look at this figure, what side corresponds to segment HF? Hopefully you said side HK. That would be segment HK, just like that should be segment. Hopefully you said segment HK would correspond to segment HF. If you have questions about that, please be sure to let me know, and I'm happy to help you. Let's look at example 2, using common parts of triangles. So if I want to know, is angle EGD congruent to angle EFH? So first, I think that identifying angles has been a little tricky for you guys. So if you have 3 letters for an angle, start at the first one listed, so in this case E, go to the second letter, G, and then D is our last letter. So I'm talking about this angle right here. And I want to know, is that congruent to E, F, H? I want to know, are these two angles congruent? And if we look at all of the information, I can see that I have a lot of congruent sides. FG would be congruent to itself. FG is congruent to FG. And DF would be congruent to G or HG. And DG is congruent to HF. Because if I have this side length that is congruent to this side length, and then we have that overlap, if I go this distance, that is the same as me going this distance. Okay, that's by the segment addition postulate, which we will use in our next slide. Okay, then since segment DE is congruent to HE, we know that these two sides are congruent, and triangle DEH is isosceles because we have 2 congruent legs on the big triangle. That means the whole thing's isosceles. That means that these angles are congruent to each other. So we want to figure out, is angle EGD congruent to EFH? And so since I've looked at all of that information, because segment DE is congruent to segment HE, and we have angle D is congruent to angle H, which we've highlighted all of that, and we know that segment DG is congruent to segment HF, we can actually say that those two triangles, EDG and EDG and EFH, we can say that those are congruent by our side angle side. And if those two triangles are congruent, that means that these two corresponding angles are congruent by CPCTC. Some of you are confused on when you can use CPCTC or what the point of it is. The way you know you can use CPCTC is if you already have two congruent triangles. Okay, because remember, these two letters stand for congruent triangles. So that means you need to have congruent triangles first. If you already have two congruent triangles, you can say that any of the corresponding parts are congruent. Okay. All right, now let's look at example 3, which is all about using the common parts of triangles. So we are given segment AB is congruent to segment DC, and segment AF is congruent to segment DE, and angle A is congruent to angle D. So I start by writing all of that given information. I look over at my picture, I see that that's all marked. That's great. Then I ultimately want to prove that triangle BFE, is congruent to triangle CEF. So I want to prove that those two triangles are congruent. So if I have given it information, I see that I have some overlap happening between those two triangles. So I'm going to start off with the reflexive property and say that the part that appears in both of those triangles I'm trying to prove, FE, I'm going to say that segment FE is congruent to segment FE, or if you said segment FE is congruent to segment EF, that's great. And then if I know that those two segments are congruent, I can try to get a bigger part of the triangle. So I look at this picture and I say, the two triangles that I've highlighted, I don't have any information about them. All of my information that I know is written on a different triangle. So I'm going to try to prove triangle ABE because that's where I have information. I'm going to try to prove that triangle ABE is congruent to triangle DCF. That should be an E. Triangle ABE is congruent to triangle DCF because that's where I have that given information. That's where that appears. And then if I can prove those two triangles are congruent, I will be able to prove that other parts of these two smaller triangles that I highlighted are also congruent. So if I look and I say that AE is congruent to DF, I can say that because I know that both AE and AF are congruent, and then I already said that FE is congruent. So that's the whole bottom of that triangle that I'm trying to prove first. That is not what I meant to happen. So now that I've done that, I have the whole bottom segment of that triangle, and then I was already given an angle, and then I have another side. So I can say that triangle ABE is congruent to triangle DCF because side, angle, side. Side, angle, side. Then, if I know that those two triangles are congruent, I can start saying that the parts of those triangles are congruent. So next, I can look at those two original triangles I'm trying to prove, BE and CF, so the diagonals, are also congruent by corresponding parts of congruent triangles are congruent. And I can also say I have two congruent side lengths. I also have two congruent angles. So angle BEA would also be congruent to angle CFE. So I now have a congruent side and a congruent angle. So corresponding parts of congruent triangles are congruent, CPCTC. And then remember, we had started out this proof by saying that FE was congruent to itself. So now I have side, angle, side, SAS. Sorry, I realized I marked the wrong side. I should have marked BE and CF. So my picture was wrong. But my proof is correct for the right side. So segment BE is congruent to segment CF, and then we have those two congruent angles, and then we have the perfect side, angle, side. All right, and our last example, example 4, which is all about separating overlapping triangles. So sometimes we get pictures that are really complex, and we have a city runs 3 triangular bus routes to various attractions. How can you draw a separate triangle for each route? Are any of the routes the same length? So I'm going to start by separating out the 3 different colors. So if I look, I have the green route, the purple route, and the red route. And when you have really complex pictures like this, separate your triangles. Otherwise, you're going to go crazy and not feel like doing any of this, maybe even more so than some of you already do. So let's separate those out by drawing separate triangles. And then if you go through the picture, you're able to then add up your measures to figure out how long things are. So if we did the green route, you could see Science Museum, Theater, History Museum, Zoo, Rose Garden, and Science Museum. Then if you go back up to your picture, you can add up all of those measures for your route to figure out how long that is. And if we look at those and we compare the different triangles, I can see that the green route and the red route have congruent legs and congruent hypotenuses. Therefore, those 2 routes are the same length because those 2 triangles are congruent by the hypotenuse leg theorem. Okay. I know that's kind of a lot, but practice dividing up triangles, redraw pictures. It will help you a lot. And then just a reminder, here are some of the theorems that you're going to use, especially with these overlapping triangles. If you have any questions at all, please feel free to reach out for some help, and I'm happy to help you. Have a great day.